these lectures. And then after class, before you go to bed in the same day, and review all the lectures and you have written down. This one will give you very, very high grade. Okay? So this is a very, very effective learning strategy. So today we are going to talk about this one very quickly, as I said. And for this, we do not have too much math inside. So, and I hope you can understand these ones also. Many students have reviewed by themselves, and that's great. So mobile rovers basic control systems. So here is the basic pictures of the concepts. What I want to emphasize is that so closed loop and this is open loop. And what is a closed loop and what is an open loop? So this is the most important concepts I want to emphasize. And the closed loop means that so this control system does not have the feedback. Right? So closed loop means that this control system has the feedback. I do not know whether you have heard this is the original, the U1, the rocket. Have you guys ever heard this one? U1 rocket that is invented by German scientists and engineers. You know that, right? Maybe you do not know, but I'm talking now. So at the very beginning, so whenever we found a target, we just use the rocket to aim at the target and then shoot and send out the rocket. The rocket goes to fight the target. However, at the very beginning, there is open loop control. Okay, so we know that the enemy aircrafts, because they are moving, they are not stationary. Do you guys agree? So then, people, the scientists, improve this idea and introduce this closed loop. You understand, guys? I want to tell you at the very beginning of human history. So this is the military history. So there we have the open loop control system. Open loop control system is that if I fight the target and I shoot the rocket, and then I don't care, I don't take care of it anymore. But usually this is at the very beginning. So this is the U1 rocket has done a lot of performed very well at the very beginning, but because as I said, all the targets are moving, so people need to improve this is control system, and then the closed loop, the control system appear. I want you guys to know that. Okay. Now currently the how the control system works. If the enemy aircraft is moving, so usually I shoot my rocket, shoot my this missile, and this missile can go and to follow this is a target until so the distance between the target and the missile, the distance becomes 0. Understand, guys? You should know that one is closed loop, one is an open loop. Be very, very careful. So so here is the feedback control. Here, so this one is I go give you this diagram. For here, input signal, error signal, and energy input. And for this is the example I just give you. And so this is the missile. Where is the missile? Now, if we do not have this closed loop, the missile will go to fight the target. However, if the target is moving and the missile missed this target, then this missile will cannot do anything. It just hit something useless. However, if there is feedback, okay, if there is a sensor in the missile, and this sensor always detects the distance between the missile itself and the target, for example, the enemy aircraft. So they will continuously change the orientation, direction, and this velocity, to make sure at the very, very end, the distance between the target and the missile itself becomes 0. You know what I'm saying, right? Becomes 0. So this is the difference between this is a open loop and a control loop. So always, so this is the driving force is is the military application. So for this control system. So error and overshoot, and you can take a look at this one. Here is one example. Previously, previously before this is the mobile robot, this content and was cut off from this course, and so usually in this course we have this is walk follow. This is the task for the students to do. And here is a mobile robot, and here is a wall, and you need to control this mobile robot to make sure this guy is going in a parallel line. So this is a very, very good example. But so this one is cut off. And we when I want to talk about the three controls, have you guys ever learned these controls algorithms in other courses? Experimentation or the control systems? Have you learned? No? Okay, then I talk about a little bit. A proportional control, and the proportional control, as the name suggests, it means that the output and the error input. The error input actually is the difference between the target and this is actual the position. So this error input are multiplied by the Kp, and Kp is a proportionality constant. So you can see, as the name suggests, it means that output is proportional to the error input. So this the people use this one to control the system. So this is a proportional control. And second one is so derivative control. The derivative control, it means that you can see, okay, the output, we use the Kd multiplied by the velocity. Now this time it is the velocity, not the distance anymore. We know the relationship between distance and velocity, right? Right, guys? We know the distance, and how can we get the velocity? We take the derivative. We take the derivative of distance with respect to time, and then we get the speed or velocity. You guys agree? So that's the reason this. So this is called the derivative control. We also have this derivative gain, a constant, and multiplied by the velocity. Okay, velocity equals the error input. Error input is the distance input. Distance error distance between the target and the missile. So this here is the derivative gain. So this is D control. So why comes twice? So PD, if you put them together, and we will have PD. PD means the output equals Kp multiplied by error input, then plus Kd multiplied D error input and dt. D error input dt is a speed, is a velocity. Okay, guys? So you should know that this error input, it is a distance. Error distance, the distance difference between the target and your missile. And I hope you guys, when I teach guys, as I said, I want you guys to pay attention. If you do not pay attention, actually, you don't need to come here. Okay? If you come here, do not pay attention, and then after class, you need to use the same amount of time, 50 minutes, to review the lecture notes. That means you use double class sessions for this. That is waste of time, to be honest. Right? Because our class policy, we do not have this is the mandatory attendance. So if you don't want, just leave here. Okay? And for your well-being, I want you guys to pay attention to what I say. Then after class, 15 minutes later, you can just forget about it. So, but you already know everything I just taught. Right? So our goal is that we use the minimum time to maximize our learning. Is that your goal? This is my goal. I never ever want to use double time to learn the same thing. No, I will not do that. Okay, so this let's come back to this one. Output, this PD is a combination of proportional and derivative. output, as I said, whenever the original input is a distance difference between the target and your missile. Okay, so this is the distance. If we take the derivative of distance with respect to time, we get the speed. So this is a PD. Come twice. The third one is the integral control. You can see the integral control output is a KI, is integral constant. Now this time we take the integration of this error input with respect to time. So that's the reason this is called integral control. So this is the third one. The third one, so PI, we can put them together, and we have PI, and you have PID. We can put all of these three control systems together. These are control algorithms together. So this is a set point. So here is this is a state, the current state. Okay, the current state. This is a set point. Set point is a target. Set point is my target. So the state means that where my missile is now. Right? So you can see this error. Okay? Ideally, if the error equals 0, and then I do not do anything. That means if the error equals 0, that means my missile catches the enemy aircraft. You understand, guys? Otherwise, if there is no 0, and so you need to do something to change the orient. As I said, change the speed of your missile, and change the orientation of your missile, change your direction of your missile, and to make sure for the next time step, the missile can still follow the enemy aircraft. Right? So here, this control algorithm, and in the quiz or exam, I might ask you guys to use your own language and to tell me how to implement. And this is a PID. Okay, what I want you guys to do is I want you guys to show me understanding of this. So for this part, I will not test your understanding of the quantitatively, and only this is a knowledge, basic knowledge. Only is a conceptual. You understand, guys? Any questions regarding this control system? So the takeaway messages for this lecture is that you should know what is the difference between the open looped and closed looped control. This is the first one. And second one is you know P, you know I, you know D, you know PID. What PID stands for? You should know that, right? But otherwise, when you take